So this is our study guide for Unit 6. I'm just going to be going over arrays and all the stuff that goes along with them. So arrays are a type of object in Java that is used to store multiple values of the same type. So we can kind of visualize them as a whole bunch of boxes, one after the other, where all the boxes are going to hold the same kind of thing. Once you have initialized an array in Java, you cannot change its size. So you can't add more boxes, you can't take boxes away. You can change what's inside of the boxes, but you cannot add more boxes to your row of boxes. That is set in stone once you created it, unless you want to completely overwrite the whole array with a new one. Now, there are two different ways that we can initialize an array. Our first way is we're going to declare our array. We are going to say what type of values are going to be stored. That set of square brackets is showing this is an array. And just like any other variable, we need to give that variable a name. And on the right side, we're going to use our new keyword. And we're saying we're making a new array, using those square brackets again, of a specific type with a specific number of elements. So however many elements we want, that's how many boxes are going to be made. So the default value for each different type in Java is going to refer to there being no information held within there. So if it's a number, you're going to get 0. If it's a character, you're going to get an empty set of quotes. If it's a Boolean, you're going to get false. And if it's any kind of object, you're going to get null, saying there's no object data here. Now, a neat fact is you don't actually need to define that variable num elements, or you don't need to give it a value before you run your program. In certain languages, you need to know exactly how many elements your array is going to be before you can create it, before you even run your code. In Java, you are able to do like user input or choose a random number for your num elements and define how long your array is going to be. So that's how we can fill an array with default values. If we want to initialize an array filled with chosen values, or values that we choose as the programmer, in our initialization on the right side of our equals, we're just going to define some list of values inside of curly braces, and all of our values should be separated by commas. Very similarly to our other one, once we have created our array here, we cannot change how many boxes there are. So if I say that my array is going to be 1, 2, 3, my array is always going to be 3 elements long. I cannot make it longer, I cannot make it shorter unless I completely redefine my array. I can change the value of my elements to different numbers, but I cannot make more numbers available. Once you have created an array, you are able to either access or update its elements by referencing their indices, or inside of a set of square brackets after the name of the array. So if I want to access a value out of my array, we're going to say our array's name, square brackets, whatever index we want to get. So if our array has 5 elements, remember indices start at 0. So our smallest index is always 0. We're going to put some number, and we're going to get whatever value is in that slot in our array. If we want to update the value of an element, we can use that same notation, our array name at a specific index, and we're going to assign it a new value. So arrays in Java are halfway mutable, essentially. We can change their contents, but we cannot change their size. Remember, indexing is always going to start at 0, so our largest index is going to be 1 less than the number of elements, 1 less than the length of the array. And we can find that value, we can find the length by using the array.length attribute, because all arrays are going to have that length value just attached to them. It's going to tell you how many elements are within this array. It's a very helpful thing to have access to. Now, if we try to access at an index that doesn't exist, let's say I wanted to access at index 7 in the above array, there is no box number 7 up here. We stopped at 4. So we're going to get this array index out of bounds exception because there is no index 7. We're going to say, hey, that doesn't exist. I'm going to crash my whole program because that doesn't exist. So we want to be careful when we're trying to access our arrays not to go out of bounds. If I want to look at every element within an array, we are going to, that process is called traversing the array. And the easiest way to do this is using a loop, which is very similar to when we traverse through strings. For loops are going to be the easiest type of loop to use, although we are also able to use while loops if we choose. I'm going to recommend for loops because their syntax is a bit simpler, especially for accessing arrays, but feel free to use whatever kind of loop makes the most sense to you. When you're working with loops, just remember that your indices are going to go from 0 to your array.length minus 1. So if you try to access a value outside that range, you will get an error. So if you are doing something inside of your loop that is accessing at index I plus 1 or I minus 1, just keep that in mind when you're adjusting your condition for your array. Make sure that you're not going out of bounds ever. So our default for loop line is going to say I equals 0, I less than array name.length, I plus plus. However, that is not always going to be the way to do it. Like we saw on the Kahoot, you can go backwards through an array. You can start at the top, go down to the bottom. You could increase by more than 1 each time if you wanted to step larger than 1 through your array. If you wanted to look at every other element, just like any other kind of for loop, we can change how we're accessing our array if we update our for loop. So just keep that in mind. Our goal is to not go out of bounds. We also discussed for each loops. So instead of accessing all of the indices and then using those indices to access our elements, which is what we do with a regular for loop, Java allows us to access every single element in an array by using a for each loop. So we're going to say for each single element in our array. So our single element should be of the same type as the values being stored in your array. No matter what type array name has, single element should match that type. So for each element, we can read that colon as the word in. So for each element in my array, we're going to do some processing. We're going to do something inside of our for loop. And the reason we use a for each loop is, one, it's much harder to get an out of bounds exception since we're not accessing indices. I don't think it's possible to get an out of bounds exception. And they're generally a little bit easier to write and read because we're not accessing at an index anymore. We're working directly with our elements. So if my array is 4, 5, 7, my variable single element would equal 4 the first time through the loop, then it would equal 5 the second time through the loop, and then it would equal 7 the third time through the loop. It's going to change its value just like I did in the previous type of loop, but instead of accessing indices, we're accessing elements directly. So the trade-off for this easier loop writing experience is that we are not able to update our array when we're using a for each loop. So just remember, if you ever want to update your array, you need to use a regular type of for loop. All right, and we discussed a variety of different categories of algorithms that we can create using arrays. We talked about 3 major types of algorithms. We talked about mathematical analysis algorithms, where we're doing some kind of math. We might do the sum of all the elements. We might find the average of all the elements. We might find the biggest or smallest element in our array. So all of these are to do with math. So obviously the elements in our array should be of a numerical type. Otherwise, we won't be able to do math with them. If we're doing an element analysis, obviously we're going to do some kind of processing based on the values of our elements. So here, we don't care what types our elements are because we're doing some processing based on their qualities, based on their attributes. So we could do things like check if all of the elements in my array possess some property. We could check if all of my elements are unique. We could check if there are consecutive pairs. If one element after the other is the same. We could do any sort of different check within this loop because there's so many different kinds of qualities that the elements in an array could hold. And our last style of array algorithm that we talked about was reordering elements style arrays or styled algorithms. So when we reorder the elements of an array, we are going to first make a temporary array that's going to be the same size and the same type as the one we want to rearrange, because we're going to store all of the values from the original in this temporary variable, this temporary array, and then overwrite our original. So we're going to loop over all of the elements. We're going to place them into that temporary array one at a time in the new order that we want. And then we're going to copy the original or the temporary over the original so that we have actually updated the order of our elements. One very useful tool in this process is the Modulus Operator. So if we're shifting left or right in our array, obviously something is going to have to loop around from the end to the beginning of the array. And if we use the Modulus Operator, this lets us never access a value that's out of bounds. If we modulus by the length of our array, then anytime we would reach the length or exceed it, we're going to reset back to the beginning. We're going to reset back to 0 or 1 or whatever and not go out of bounds. So Modulus is a very, very useful tool in this scenario. Now, no matter which of these styles of algorithm you're implementing, we have a very rough skeleton of what our code is going to look like. There you go. So we're going to initialize and declare our array very first. Obviously, we're going to make some kind of a tracker variable or we're going to make our temporary array, depending on which style of algorithm we're working on. If we're doing a math thing, we'll have to make some integer to keep a count or keep track of what we're looking for. Our temporary array obviously is going to be the same type and size as our original, just like I said before. We're going to loop over all of the elements in the array, preferably with a for loop because those are easier to write. And then in there, we are going to perform some kind of a mathematical operation. We might check the properties or place our elements into our temporary array, depending on which of the types of algorithm we are running here. And then at the end of our loop, we're going to report our results. We're going to say, here are the end results, here's the new array, or here's the result of what we found after doing this analysis. And there we have it. Any questions, anything that I missed in here that you'd like me to recover? Good. All right.